Have you ever wondered how your phone predicts your next word? It seems almost like it knows what you're thinking, right? Or how streaming services suggest shows you might enjoy. They seem to understand your taste better than some of your friends. It's like magic, isn't it? But unlike magic, there's a logical explanation behind it, but there's no sorcery here, just the power of machine learning, or ML. This technology is the driving force behind these seemingly magical predictions. Machine learning is a branch of artificial intelligence, AI, that empowers computers to learn from data without explicit programming. It's like giving them the ability to think and adapt. Imagine teaching a child to ride a bike. It's a process filled with trial and error. You don't tell them exactly how to move each muscle, do you? Instead, you provide guidance and let them figure it out. Instead, you let them experiment, learn from their stumbles, and eventually master the skill. This is similar to how machine learning works. Similarly, machine learning algorithms learn from data, identifying patterns and making predictions. They improve over time, just like a child mastering a new skill. It's like giving computers a set of eyes to observe, a brain to analyze, and the ability to get better over time. They become more accurate and efficient. This technology is transforming our world, from healthcare to finance, transportation to entertainment. Its applications are vast and ever-growing. So, let's embark on a journey to demystify machine learning, explore its core types, and understand how it's shaping our future. Together, we will uncover the secrets behind this invisible hand of intelligence. At its core, machine learning is all about data. Data is the lifeblood that drives these intelligent systems, enabling them to learn and evolve. Think of data as the fuel that powers these intelligent systems. Just like a car needs gasoline to run, machine learning models need data to function effectively. The more quality data you feed them, the better they become at their tasks. High-quality data acts like premium fuel, enhancing the performance and accuracy of these models. There are three primary types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Each type has its unique way of processing and learning from data. Each type tackles a different kind of learning problem and uses distinct approaches to extract knowledge from data. These approaches are tailored to solve specific challenges and achieve particular goals. Imagine you're teaching a dog new tricks. This analogy helps to simplify the complex concepts of machine learning. In supervised learning, you show the dog a treat and give it a command, rewarding it when it performs the trick correctly. This is similar to how algorithms learn from labeled data. This is analogous to providing labeled data to an algorithm, where the input is paired with the desired output. The algorithm learns to make predictions based on this input-output pairing. In unsupervised learning, you let the dog explore on its own, observing its behavior and trying to understand its preferences. This method allows the algorithm to identify patterns without predefined labels. This is like giving the algorithm unlabeled data and asking it to find patterns and relationships on its own. The algorithm clusters the data based on inherent similarities. Reinforcement learning is like teaching the dog through a series of rewards and penalties. The dog learns to associate actions with outcomes, refining its behavior over time. The dog learns by trial and error, receiving positive reinforcement for desired actions and negative reinforcement for undesired ones. This iterative process helps the algorithm improve its decision-making. Now let's delve deeper into each type, using relatable examples to illuminate their inner workings. By understanding these examples, we can better appreciate the power and potential of machine learning in our everyday lives. Supervised learning is like having a teacher who guides the learning process. The algorithm is given a set of labeled data, which means each input is paired with its corresponding output. The algorithm's task is to learn the relationship between the inputs and outputs so that it can predict the output for new unseen inputs. Imagine you're building a spam filter for your email. You would train a supervised learning algorithm on a dataset of emails labeled as either spam or not spam. The algorithm would learn to identify patterns in the text, sender, and other features that distinguish spam from legitimate emails. Once trained, the spam filter can analyze incoming emails and classify them with impressive accuracy. This is just one example of how supervised learning is used in countless applications, from medical diagnosis to fraud detection. One of the most fascinating applications of supervised learning is image recognition. Think about how easily you can unlock your smartphone using facial recognition. This technology relies on supervised learning algorithms trained on vast datasets of faces. These algorithms learn to identify the unique patterns and features that distinguish one face from another. They can even recognize faces in different lighting conditions, from various angles, and with different expressions. Beyond security, image recognition powers a wide range of applications, including medical imaging analysis, self-driving cars, and even identifying individual animals in the wild for conservation efforts. It's a testament to the power of supervised learning to automate complex tasks that were once thought to be the exclusive domain of human perception. Section 5. Unsupervised Learning Unveiling Hidden Patterns. Unlike supervised learning, unsupervised learning deals with unlabeled data. It's like exploring a new city without a map, trying to find your way around by observing patterns and landmarks. The algorithm's goal is to discover hidden structures, relationships, or anomalies within the data. Imagine you're a marketer trying to understand your customer base. You have a data set of customer demographics, purchase history, and browsing behavior. Unsupervised learning algorithms can help you segment your customers into distinct groups based on their shared characteristics. This information can then be used to tailor marketing campaigns, personalize recommendations, and optimize pricing strategies. Unsupervised learning is a powerful tool for exploratory data analysis, helping us uncover insights that would be difficult or impossible to find using traditional methods. Section 6. Recommendation engines, unsupervised learning in action. Have you ever wondered how streaming platforms seem to know your taste in movies and TV shows so well? The answer, in part, lies in unsupervised learning, specifically a technique called collaborative filtering. Collaborative filtering algorithms analyze your past viewing history and compare it to the preferences of millions of other users. They identify users with similar tastes and recommend movies or shows that those users enjoyed but you haven't seen yet. This personalized approach to recommendations has revolutionized the way we consume entertainment. It's also used by online retailers to suggest products, by music streaming services to create personalized playlists, and by social media platforms to connect you with like-minded individuals. Section 7. Reinforcement learning, learning by trial and error. Reinforcement learning is perhaps the most intuitive type of machine learning, as it closely mimics how humans and animals learn. It involves an agent interacting with an environment and learning to maximize its rewards through trial and error. Imagine teaching a robot to navigate a maze. The robot starts with no knowledge of the maze's layout. It explores the maze, receiving positive reinforcement such as points for making correct turns and negative reinforcement such as penalties for hitting walls or going in circles. Over time, the robot learns to associate actions with their consequences and develops an optimal policy for navigating the maze. This approach has been successfully applied to a wide range of problems, from robotics and control systems to game playing and resource optimization. Section 8. Game Changers, Reinforcement Learning in Gaming. Reinforcement learning has achieved remarkable feats in the realm of games. One of the most notable examples is AlphaGo, a program developed by DeepMind that defeated the world champion Go player. Go is an ancient board game known for its complexity and strategic depth. AlphaGo mastered the game by playing against itself millions of times, learning from its mistakes and refining its strategies through reinforcement learning. This breakthrough demonstrated the potential of reinforcement learning to tackle complex problems that require strategic thinking and adaptation. Beyond games, reinforcement learning is being explored for applications in robotics, autonomous vehicles, and even personalized medicine. Section 9. The real-world impact of machine learning. Machine learning is no longer a futuristic concept. It's deeply intertwined with our lives, often in ways we may not even realize. It has seamlessly integrated into various aspects of our daily routines, influencing decisions and actions without us even noticing. From the personalized recommendations we receive online to the fraud detection systems that protect our financial transactions, machine learning is omnipresent. Machine learning is quietly working behind the scenes, making our lives easier, safer, and more efficient. It's the invisible hand guiding many of the technologies we rely on every day. In healthcare, machine learning is being used to develop new drugs, diagnose diseases with greater accuracy, and even personalize treatment plans based on a patient's genetic makeup and lifestyle. This means more effective treatments and better patient outcomes. In finance, it's helping to detect fraudulent transactions, assess credit risk, and provide personalized financial advice. This not only protects our money, but also helps us make smarter financial decisions. The transportation industry is undergoing a revolution thanks to machine learning, with self-driving cars poised to transform the way we commute and transport goods. These advancements promise to reduce accidents and improve traffic flow. These are just a few examples of how machine learning is already having a profound impact on our world. Its potential is vast, and its influence is only expected to grow in the coming years, touching even more aspects of our lives. Section 10. Shaping the future machine learning's potential. As machine learning continues to evolve at an unprecedented pace, its potential to shape our future is virtually limitless. From addressing climate change to eradicating diseases, the possibilities are truly inspiring. Imagine a world where renewable energy sources are optimized using machine learning algorithms, reducing our reliance on fossil fuels and mitigating the effects of climate change. Envision healthcare systems that leverage machine learning to provide personalized and preventive care, leading to longer, healthier lives. The future holds immense possibilities, and machine learning will undoubtedly play a pivotal role in shaping it. It's a tool that has the potential to solve some of humanity's most pressing challenges and create a better future for all. Section 11. Join the journey into the world of tomorrow. Machine learning is not just for computer scientists and engineers. It's a field that touches every aspect of our lives, and understanding its basic principles is becoming increasingly important for everyone. I encourage you to continue exploring the fascinating world of machine learning. Read articles, watch documentaries, and engage in discussions about the ethical implications of this powerful technology. The more we understand about machine learning, the better equipped we'll be to harness its power for good and shape a brighter future for generations to come.